Okay, 4.3. Suppose you have 60 pennies arranged into 12 stacks with 5 pennies in each stack. The 12 stacks are arranged in 3 rows with 4 stacks in each row, as shown in figure 4.21. For each of the following expressions, explain how to see the pennies grouped in that way. Your explanation of the grouping should not involve rearranging the pennies. Okay, so that means each one of those expressions will be about the same stack. So we'll just draw this stack 4 times and look at the different ways to talk about them. Okay, so we have here 3 groups of 20 to start. So 3 groups of 20. And the 3 groups are here. So we see 3 groups. So 3 rows. And then we have to look at what 4 times 5 means, right? 4 groups of 5. So each stack is a group within a group, right? So what we have for 3 times parentheses 4 times 5 is we have 3 rows of 4 stacks of 5 pennies. So we have 3 rows of 4 stacks per row, each row with 5 pennies, or each stack with 5 pennies. So 3 rows of 4 stacks of 5 pennies in each stack. Okay, so we didn't rearrange the numbers and we kept with the 4 groups of 5 and 3 groups of 4 times 5. Okay, in the next one, B, we have 12 groups of 5 to start with. So to get us started, we need 12 groups of 5. The 5 is going to be the pennies in each. So this time around, our 12 groups are the stacks themselves, right? So again, we need to look at what 3 groups of 4 means, right? So we have 3 groups of 4 groups of 5. So this is 3 rows. Let's see. How am I wording this differently? Right? It's a kind of almost worded the same. 3 rows of 4 stacks. Three rows of 4 stacks. Giving us 12 stacks. And then each stack has 5 pennies. So this first one, then 3 rows. Each with, I guess, to try to differentiate, right? Each with 4 stacks of 5 pennies, making 20 pennies each. Okay, so this one here is a little harder to circle just because we're going to have 12 groups. I don't know if they ever meant for us to circle them, but we have 12 groups, the groups themselves being made of these rows and columns type of thing. Okay, so let's look at 5 times 3 times 4. So this will be 5 groups of 3 times 4, right? So the pennies are in 5 layers. Each row, right? So we have a 3 times 4. So each layer has 3 rows and 4 pennies in each row. That's awkward. Okay, so this is a let's see. That's a row. Okay, so each penny has a layer. So there's a layer, and then because there's 5 pennies, so oh, I need space. That's part of my problem. All right, I'm gonna move it up a little. Okay, so pennies are arranged in 5 layers. And then each layer has 3 groups of 4. So 3 rows. So that being our top layer. If we were just looking at one stack, right, then the top layer, and then we count all of the top layer, and then the second one down in the stack, we count all of that layer. It's weird. I don't like it, right? But what we have is each layer has 3 rows of 4 pennies. So there are 12 pennies in each layer, right? It's weird. But that's what we have, right? So the layer itself is the group. And then we have 3 rows and 4 pennies in each row for part C. Part D, let's see if we can get this one. 4 times 3 times 5. 4 is the stacks. So we'll have 4 stacks. And then I'm thinking, or 4 columns. There we go. 4 columns. Each column has a set of 3 stacks, and each stack has 5 pennies. I don't mind this one. The hardest one for me was C. That was awkward. Okay, let's look at D. D's back to something like A. So 1, 2, 3, 4 columns, right? Let's see. So for D, oh, scoot it up a little. Give myself, oh, maybe me scoot up a little. Okay, so for D, I have 4 columns, each with 3 stacks with 5 pennies per stack. So the only thing we didn't do in D and A that we did in B and C was articulate the multiplication. We said it, we just didn't write it, right? So in D, then we have each with 3 stacks of 15 pennies per stack, giving 15 pennies in each column, right? Something like that. That way we can tell the number of groups is the column, and then we broke down what the 15 was, but then we also gave the 15 so that it's 4 times 15, but also it's 4 times 3 times 5, right? And let's finish out the blue one as well. So in the blue one, we had 3 rows, each with 4 stacks of 5 pennies, which is 3 rows of 20 pennies, right? Okay, so what we did was we take the same stack of pennies. We didn't rearrange the pennies, we left them. We just counted them differently, right? So one time we counted them horizontally, one time we counted them vertically, one time we just sliced off the top and counted the top, and then pushed all the top off, counted the second, pushed all the second off, counted the third layer, right? And so we counted this same amount of pennies 4 different ways. And those ways involved the commutative property and the associative property. So let's clear this out and write the properties down. C was definitely the most difficult for me. But lean into the definition of multiplication, right? Where we have 2 factors. The first factor is the number of groups. The second factor is the number of items per group. Okay, so what we want to express now is the commutative property and the associative property. So A times B has the same value as B times A. We see, let's see. Let's write. I was trying to see if we see one easily here. But I see more commutative properties. So let's try that. Oh, that one's commutative. I see more associative. Okay, and then this one, A times B times C and A times B times C. So we have A times B times C, or A times the product of B times C. So this one is our associative property. Okay, that's the one I was looking for a second ago, I think. But let's see. We've got 3, 4, 5 for A and 3, 4, 5 for B. So let's look at that. That one on number B is written 3 times 4 in parentheses times 5. And on A, it's written 3 times 4 times 5. So between A and B, we've used the associative property, where we've just moved what we're grouping to a different group first, right? So, and even in the definition of multiplication, we have 3 groups of 20 versus 3 times 4 groups of 5, right? So that didn't come out very well, but 3 groups of 4 times 5 versus 3 times 4 groups of 5 barely came out better. Okay, let's see. And then in between C and D, then we can see some commutative property, right? Where a term actually physically moves. Here we have, let's see, 3, 4, 5. Let's look at between B and C. So in B, we have 3 times 4 times 5. And in C, we've moved the 5 to the front, and we've moved the group to the back, right? So just in terms of pure numbers, right? So there we've used between B and C, we've used the commutative property. So we have examples here of the commutative property. Usually a place we see it a lot of the time is with area, where we'll talk about length times width being the same as width times length, right? So it doesn't matter generally to us if we're taking length times a width or a width times a length, right? We look in terms of arrays to help us explain, right? So for example, this could be 5 columns of 3 squares per column. And that has the same value. It's the exact same rectangle as looking at 3 rows, each with 5 squares per row. So whether we look at L times W or W times L, those produce the same amount of squares. It produces 15 squares here in our example. And a place we see the associative property then is with volume, length times width times height, length times width times height. So if you look at your room, then you can take the area of the floor and stack it to the ceiling to fill the room, right? So volume that way, take the area of the floor, stack it to the ceiling. Or you can take the area of the wall and stack it out the distance of the room. And that will also fill the room with volume, right? So here in this one, we group the area of the wall and then we stack it times L to the, or across the room. Let me erase that a little. We stack it through the room to other wall, something like that. You get my gist though, right? So across the room to the other side. And that's volume, right? Which, you know, you don't want to see me draw a cube, but here goes. Nope. Sorry. Terrible, terrible cube. Okay. Removing something, you're commuting. So think of the root word commute. You physically go from Berlin to Albuquerque versus associative property, where you're just associating the W here with a different term first. Well, here factors, right? So we want to find the product of L and W first versus finding the product of H and W first.